Alright, welcome to week 5 of NTI, the domain of composed functions. We are going to be reviewing domain before we get into this. This is the inputs of the function, and a number is not considered in the domain of the function if the output, or if any output, is not produced. So a few conditions apply to us here. There are more, but not in the scope of this class. So there cannot be division by 0, so we cannot have 0 in the denominator. Number 2, there are no negatives under an even root. We cannot take the square root or the fourth root of a negative number. Number 3, no negative arguments in logarithms. So a logarithm cannot have a negative input. And then when it comes to functions with the domain of all real numbers, a line, so any line will work, polynomials of any degree, so something that looks like y equals x to the 5th plus 5x minus 4, for example, would always have a domain of all real numbers. Sine and cosine have a domain of all real numbers. E to the x and a lot of different any base to the x will produce a domain of all real numbers. And then odd root radicals, so like the cube root of x or the 17th root of x, would produce a function with domain of all real numbers. So we'll keep that in mind as we tackle the questions this week in quizzes. So our directions here are to perform the given operation and then determine the domain. So to start these off, we have to first understand the setup of these functions with function notation, and write h of x with our specific functions. So we got 3x minus 9 in the numerator and x squared plus x minus 12 in the denominator. And then we have to realize how to find the domain. And really, these are both. This is a polynomial, well, a linear function on top, and then a polynomial on the bottom. Those are fine, but it would not be great if we had a denominator, if this polynomial produced a denominator of 0. So we're going to solve for 0 and determine when this cannot be, determine when the domain has an input that's not allowed. So from the work that I've done here, it's easy to see that x equals 3 and x equals 4 are not going to give us an output because we would be dividing by 0. So our domain would be negative infinity to negative 4, union negative 4, not inclusive, to 3, union 3 to infinity. So I'm using interval notation. These U shapes bind every interval together, but exclude negative 4 and 3. And this is how you'll see the answers written in quizzes as well. For the second one, we have a composition of functions between a square root and a linear function, and we'll write that pretty quick. So g of x would go inside the square root. So I've got h of x is the square root of 5x plus 1. Okay, great. So now that we know this is a square root function with this input inside of it, I have to determine where is the 5x plus 1, where is that less than 0? So I'm going to take 5x plus 1 and set that equal to 0, and then figure out which side of 0, so which x inputs will produce negative inputs. I know that x has to be greater than or equal to negative 1/5. So for example, negative 2 is not allowed. If I did negative 4/5, this is not going to be allowed. Because it's less than negative 1/5. So you can check that, but it's really important to note that you can have a 0 under a radical, just not a negative number. So the domain here is going to be including negative 1/5 and then going towards infinity. Alright, last example. We're looking at division between a linear function and a trig function, specifically sine. So back at the beginning, I mentioned that there were two trig functions that have a domain of all real numbers. The rest of them, unfortunately, do not. So with this composition of functions, h of x is equal to 2x minus 4 over sine x. So this is basically 2x minus 4 times cosecant x. So we know that there are going to be some holes in this domain, not because of the linear function, but because of the trig function. So I'll reason out where the denominator is 0 by thinking about when sine is 0, and that's true at 0, pi, 2 pi, and 3 pi. So that would mean we would have a domain of all real numbers except 0 plus or minus pi n. So every number except every pi value, we would get an answer for this division of functions. So this is the last week before AP tests, and the last thing I wanted to say was during AP test we'll have a 2-week assignment. So you should be able to find time in between your AP test schedule to complete the weekly Precal assignment. So instead of 2 assignments in those 2 weeks for AP tests, you'll have 1 assignment for 2 weeks. But I'll talk to you all this week, and see you later.